The following content has been generated with artificial intelligence under minimal human supervision. The data presented may contain errors or inaccuracies. The opinions expressed in this content do not necessarily reflect the vision, position, or values of DigiAll. We recommend verifying critical information with additional sources before making decisions based on this content.
Welcome to DigiAll Tech News. Today is Wednesday, July 15th, 2026. I'm Kylie Brooks, and this is where technology becomes clear and engaging. Mistral AI has introduced Robostral Navigate, an 8 billion parameter model that lets robots follow plain language directions using only a single R.G.B camera. The Economist is warning that China's open-source AI pitch, framed as a shared asset for humanity, is also a contest over geopolitical influence. CoreWeave is exploring Wall Street-style hedges to protect itself if memory and storage chip prices fall after long-term supply deals. At MIT, the JARVIS challenge tested whether AI copilots can help students design, build, and fire a real subscale jet engine. The White House has launched Gold Eagle, a cybersecurity clearinghouse meant to help patch software flaws found by advanced AI models. Let's start with robotics, because this is a bet on making navigation less sensor-heavy. Mistral AI's Robostral Navigate is an 8 billion parameter model designed to follow natural language instructions through complex indoor and outdoor spaces, with one R.G.B camera, and without LiDAR or depth sensors. On the R2 RCE benchmark, it reached 79.4% success in scene validation environments and 76.6% in unseen ones. Mistral says that beats the previous best single-camera system by 9.7 points and the best multi-sensor systems by 4.5 points. The model was trained entirely in simulation on roughly 400,000 trajectories across 6,000 scenes, then improved with online reinforcement learning called CISPO, which added another 3.2% success rate. In practical terms, the appeal is obvious. Fewer expensive sensors could make useful robots simpler to deploy across wheeled, legged, and flying machines. But the real-world test is not just whether a robot can win a benchmark, it is whether this approach holds up when latency, power use, edge hardware, and messy physical environments start deciding what works. Now to open-source AI, where the word open is doing a lot of political work. The Economist frames Xi Jinping's scheduled appearance at the World Artificial Intelligence Conference in Shanghai on July 17, 2026, with a satirical suggestion. Instead of prepared remarks, he could sing the 1960s anthem, "I'd like to teach the world to sing." Behind the joke is a serious argument. America's pursuit of AI dominance raises real global concerns, but China's alternative is not being presented as neutral. Beijing describes its open AI models as a shared asset for all humanity, with special appeal to users in less wealthy countries, and it has pushed for the United Nations to lead a global initiative. The article contends this framing is a strategic counter to American influence, rather than a benign alternative representing genuine openness. This CoreWeave story is where AI infrastructure starts to look less like pure software and more like an airline managing fuel risk. Reuters reports that CoreWeave, the NVIDIA-backed AI cloud company that went public in March 2025, is in early-stage talks about financial derivatives, including put options, to hedge against a possible future drop in DRAM and storage chip prices. The tension comes from long-term supply agreements with Micron and SanDisk that include guaranteed price floors. Those floors protect suppliers if the market turns down, but they can leave CoreWeave exposed if spot prices fall sharply, while it is locked into higher contract prices. That matters because memory and flash storage prices have risen during the AI infrastructure boom, while the chip market is historically cyclical. SK Hynix and Micron expect new manufacturing capacity to be fully ramped in early 2028, which raises the prospect of future oversupply. No hedges have been executed, and the talks are preliminary. Still, the signal is important. Securing enough chips for AI growth can create the next financial risk, especially when the buyer is trying to turn volatile hardware inputs into dependable cloud margins. The JARVIS challenge at MIT sounds almost cinematic, but the work was very physical. 31 undergraduates from nearly every School of Engineering department formed 7 teams and had 4 weeks to design, fabricate, assemble, and test a subscale single-spool gas turbine aero engine. The target was 50 to 100 pounds of thrust on Jet A fuel, with 5 60-second runs. The students had full design freedom, access to MIT machine shops, tools like SolidWorks and ABAQUS, and unlimited frontier language model use through MIT's Parley platform, all under safety oversight from faculty and Lincoln Lab engineers. 1 team withdrew early, 3 reached the finals, and Fast and Fractured achieved first attempt combustor ignition before suffering a rotor rub and seizure during hot fire. The winning team, 811 crew, delivered a successful engine start, a Jet A transition, and net thrust. What I find most useful is the split result. AI helped summarize textbooks, teach software, source vendors, build spreadsheets, compare architectures, and even act like a project manager. But teams also ran into hallucinations, overconfident answers, sycophancy, and a lack of physical intuition. So the lesson is not that AI can simply build a jet engine, it is that young engineers may move faster when they can challenge the tool, test its output, and keep manufacturing reality in charge. Finally, cybersecurity, where the verified public details are still narrow. The White House has launched Gold Eagle, described as a clearinghouse to help federal agencies, critical infrastructure operators, and AI developers patch crucial software flaws uncovered by advanced AI models. The announcement, published July 14, 2026, is high level, and the verified details stay limited. It is designed to help agencies, critical infrastructure operators, and AI developers collaborate to patch critical security flaws uncovered by advanced models. Today's throughline is control. Robots may need fewer sensors, but still need proof outside benchmarks. OpenAI can expand access, while carrying geopolitical weight. AI cloud providers are learning that chip supply comes with commodity risk. Engineering students are finding that copilots help most when humans stay in command. And cybersecurity officials are launching new clearinghouses to handle software flaws discovered by AI. Thank you for staying informed with DigiAll Tech News. We'll be back with more updates as they develop.